Okay. Hello? Okay, so this is kind of a unique video. I'm making it on the basics of trigonometry. So, otherwise known as just trig. But a lot of people ask for this, so I kind of wanted to make a video on it. So, trig is very fundamental. It's a fundamental understanding that engrosses a lot of mathematics. So, it arises from, and I'm going to do my best to draw a circle here, but it won't be amazing. So it arises from the unit circle. So the unit circle is a circle with a radius of 1. So it intersects each axis at one distance away from the origin. So what is very special about the unit circle is we can represent things in trigonometry called sine, cosine, and tangent. Usually represented as sine of theta, cosine theta, tangent of theta. Well, where does that come from? So let's take any point on the unit circle. Let's take this point right here. I know it's a very poorly drawn circle, but let's say this point is, um, I don't know, 4/5, 3/5. And let's say that we could even just give it xy for now. That's probably better. Um, So let's say we want to find we know that the radius of this point is 1. And we want to find, okay, well, if we know that, and we know the angle theta, what is this x distance and what is this y distance? So the sine in theta and cosine of theta give us expressions that help us solve this. So what is sine of theta? Oh, I wrote this completely backwards, sorry. Um, Sine of theta is the y value, by the way. It corresponds to the y component, and cosine theta corresponds to the x component. So let's say we are trying to find uh, if let's say it's 45 degrees. So let's say theta equals 45 degrees, which in radians, this is another thing you could cover. I could cover another video if you want. Just let me know. It is equal to pi over 4. Basically, it's pi is the equivalent of 180 degrees, and so 180 divided by 4 is 45. Um, so let's say we're trying to find the lengths at 45 degrees. Well, we know that. Okay, so we know theta is equal to 45 degrees. And we know that this length, y, is equal to sine of 45 degrees. So we can say sine of 45 degrees, or sine of theta, is equal to this length y over 1. Okay, so y is just going to be equal to sine of theta, since the radius is 1. So the nice part about the unit circle is that since the radius is 1, y is just sine of theta and x is equal to cosine theta. If the radius wasn't, it would be like y equals some number a sine theta and x equals b cosine theta. That's all that would change. But in this case, so sine of 45 degrees equals y, and then it turns out the sine of 45 degrees is 1 over rad 2, or rad 2 over 2. Okay, so let's say, let's say Oh, first of all, you should probably know, this would be smart. Just a rule of thumb is when people try to remember, how do I calculate sine, or how do I calculate cosine or tangent? So first of all, sine is denoted as so, cosine is ka, and tangent is toa. What does this mean? Is this just gibberish? It's not. So this means that sine is equal to opposite divided by hypotenuse. So sine equals hypotenuse, or opposite divided by hypotenuse. So sine would be calculated by taking this length and dividing it by this length. And doing that, you get 1 over rad 2. So that's it for 45 degrees. For other lengths, it changes, obviously. So then let's say ka. So ka is CAH, which is cosine, is adjacent over hypotenuse. Adjacent is the length that is closest to the angle theta. Opposite is the angle is the side that is opposite to the angle theta, and the hypotenuse is the longest length of the triangle, the radius in the unit circle. I know I said triangle, so weird. But cosine, so cosine is then equal to adjacent over hypotenuse, and tangent is opposite over adjacent. So you might notice something. Tangent is equal to sine divided by cosine. That's the easiest way really to find tangent, is dividing sine by cosine. So let's say we had this, we wanted to find the tangent at 45 degrees. We would do sine of we would calculate sine of 45 degrees, and then we would calculate cosine of 45 degrees and then divide the two and find tangent. But in most cases, it's easier just to find this length, the opposite, and this length, the adjacent, and divide the two. So it would just be over A is equal to tangent. So kind of a very brief explanation. So then there are a couple uh, truths with trigonometry that help out a lot in upper level mathematics, and are kind of cool. So let's say we have this triangle. I'm gonna move it over here. So it's this exact same triangle. It's not. It's the exact same triangle. It's similar. So let's say we have this length x, and we have sine of theta and cosine of theta. Well, in the unit circle, this length is 1. And since we know that this is a right triangle, since they're meeting at the x-axis and it's going to the circle, you can kind of see by the picture, we know that by properties of right triangles, sine squared theta plus cosine squared theta is equal to, or the square root of that is equal to 1 squared, or is equal to 1, because a squared plus b squared equals c squared. What does this tell us? Well, it tells us now if we square both sides, the 1 will remain a 1. It means sine squared theta plus cosine squared theta equals 1, which is really kind of obvious if you think about it, because any point on the unit circle that has any value of sine and cosine for any angle theta, it's going to give us 1 as the length of the radius, because it's the same radius. So it's kind of really interesting. So if you do this for any angle theta, and I mean any, it'll give you the same thing. Now you might ask, so what happens if this radius is not 1? What if it's 2? Well, let's say it's 2, okay? And let's say one of these, I can't do the math right now, but let's say it's shifted by some number a for sine of theta and some number b for cosine of theta. Because that's all it would really do. It would make the circle bigger in both directions evenly. So so let's say we have that. So it's this times this is equal to 2 squared, which is equal to 4. Well, what you're going to notice is that when you factor it out, divide, and you take the square root, you're still going to get 1 every single time. Any value of it is going to give you the when you add these two, it's going to give you the exact number 1, so that when you multiply these two things, and a and b will actually be exactly equal since it's a circle. So you get a times sine of theta, sine squared theta, plus cosine squared theta is equal to 4. And that proves that a is 4 in this case. So so that means that in any angle, for any angle here, they're going to be equal to the exact same thing. So where does this come into play kind of down the line? So let's say you have some expression for cosine. Like let's say you have a system of equations, and and you have some sine squared theta term over here. sine squared theta, and you have y, and you have cosine squared theta. Well, you can represent this now, since 1 equals sine squared plus cosine squared, you can represent this as 1 minus cosine squared. So that means that this equation can be related to this equation. And it's really important because it kind of ties everything together. So the lengths of the triangle are purely dependent on the angle theta. It's a really cool relationship. So yeah, so just let me know if you have any more comments. I can cover polar coordinates, spherical coordinates, cylindrical coordinates, any of that. So just let me know in the comments. Thanks for watching again. I know a lot of videos. Yeah, thank you. Have a good day.